Okay, so I just wanted to show you a little bit of a visual video because I think this topic of ions dissolving in water is not very difficult, except that it is very visual, and so when you're taking this online, it's sort of hard to see it. So I wanted to show you what actually happens when the sodium chloride gets dissolved in water. So we know sodium chloride, here's the formula, NaCl. Now let me just shake some in there, and you can see when they dissolve in water that the sodium ions and the chloride ions separate from each other, and now they're all individually swimming around in the liquid. Let me do that again. I'll remove some and try it again. So you can see the sodium and the chloride. All right, so let's say I put 10 sodium chloride ions into the solution. You can see over here that I have 10 sodiums and 10 chlorides. So for every one of the complete ion I put in, I get one of each of these. And that's important to remember. So if I want to represent this as dissolving, let me come down here, see if this works. I can write this. So when NaCl dissolves in water, it breaks apart into its ions. And so I can write this as Na plus Cl negative. So that's how I represent NaCl. If I put the little AQ after it, that means that it's aqueous and it's dissolved in water. All right, but let me show you one more thing back up here on the screen. We know, and if you look at the PowerPoint, you can see this, but if I can show you the actual little pictures of what's happening in the water. Let me reset this and try it again. So you can see that we've got hydrogen bonding happening between the water molecules, where a negative end of water, the red end, is attracted to the positive end of water. When I put salt inside, you can see what happens is the water separates them out. And now the positive charge is surrounded by the negative charges of water, the negative ends of water, and the negative chlorine is surrounded by the positive charges of water. And so they separate because the water gets in between them. But what I wanted to show you were a couple of other things. So let me remove the solute and start. Now what happens when I put CaCl2 in the water? Okay, let's shake it. You can see again that all the different ions have separated, but notice if we look over here, the calcium and the chloride are now different amounts. Okay, you can see that the chloride ion, there's twice as many as the calcium. So the calcium, there's one calcium and two chlorides for every ion that goes in, and then they separate it into these three different parts. You can see here the smaller dark green one is the calcium, and the bigger light green one are the chlorides, and you can see that there's twice as many chlorides as calcium. So the chlorides don't stay together and the calcium doesn't stay with the chlorides. Let me just do that one more time and watch what happens. Okay, so there's twice as many chlorines for every calcium, and then when they separate, we have they all separate into different parts, and there's twice as many chlorines. See if it'll let me shake some more in there. I love watching this. Okay, so they've separated into different things. So let me see if I can show you back down here on my paper. How would we represent this? Okay, I've got my calcium and my chloride. Well, realize that calcium and each of the chlorides separate into different particles. So there's three particles altogether. So the way that we represent this is to write the calcium ion, and calcium has a +2 charge. It's in the second column, and so it has a +2 charge. And then, and what's a real common mistake is students want to keep those two chlorines together and keep the 2 down there, but instead we write it like this, because each of the chlorides now are separate from the calcium and separate from each other. So we have one calcium and 2 chlorides for every one of these that goes in. So the 2 comes out front. All right, let me show you one other little thing here. Always our polyatomic ions like to make a lot of trouble for us. So I wanted to show you what happens. Let me remove this solute. and go over here. You can play around with the different solutes. And I'm going to show you what happens when sodium nitrate. Let's see if that is kind of, there we go. Now it's not so, there we go. Okay, so sodium nitrate, when I shake that, what I want you to notice, look over here on the key, you've got sodium, which is a little red, a little purple ion, and then nitrate. Let me see if I can zoom in even a little bit more. Let it focus in on it. Come on now. Focus in. Maybe it's too close. Okay, come on now. Sorry about that. Let me see if I can focus that in. There we go. So I guess you can't get much closer than that. But if you look, you can see that the nitrate ion, which is a polyatomic ion, is a little grouping that's a -1 charge. So NO3 has one little nitrogen and 3 oxygens all grouped together as a negative ion. Now, polyatomic ions don't separate. They stay together as a group. So watch what happens when we shake the sodium nitrate. You can see that the sodium separates and the nitrate separate, and so we have sodium and we have nitrate in there, and they're 1-to-1 because they happen to be 1-to-1. So, you know, if it helps you to put a parenthesis around the nitrate to remember that that stays together as a group, that could be helpful. So as a last thing, let me write down here on my paper. Let's let it focus for a second. NaNO3, when I break this apart, the Na is a Na plus, and the NO3 is a negative ion, nitrate, NO3 minus. And so the sodium and the nitrate separate. You know, if it helps you to remember that nitrate is a polyatomic, and we have one of those and one sodium. So let's do one or two a little bit more difficult ones with polyatomic ions, and see if I can do these for you. So what about if I have Na2SO4? Well, now SO4 is another polyatomic, that's sulfate, and sulfate has a -2 ion, and that's why it's paired up with 2 sodiums. So this one, when it breaks apart, we're going to have the 2 sodiums will pull apart from the sulfate, so we'll have 2 sodiums. But we only have 1 sulfate. So if I go back over here and remind you that sulfate stays together as a group, I have 1 sulfate. Let me do one more really complicated one. Cobalt phosphate. How would I break that apart? Actually, it doesn't dissolve in water, so let me cross that off for you. We'll do one more. Let me think about it. What if we have calcium and nitrate? Okay, calcium is a +2, so we have 1 of those, and then I have 2 nitrates. So that's just a little primer on how to pull apart ionic compounds. There's probably some other videos that you can find on YouTube, which I also have linked on Blackboard, but I just especially wanted you to see the little video of or the interactive and see what's happening there.